Antonio Project present FSRU Part 2 Indirect Glycol Water Heater Regasification.
Hello everyone, welcome back to my channel. This is the continuation of my series video about FSRU story. This video is part 2 about regasification system using glycol water heater indirect regasification system. In my previous video, we have discussed about several instruments used for regasification process, and in this video, we will explore the essential process of LNG regasification on FSRU, including the operational mode, BOG saving technology by using recondenser system, which is also applied for FSRU regasification system. In this recent year, FSRU built with flexibility. FSRU can be operated as LNG carrier in LNGC mode, as well as FSRU in FSRU mode. Then, how is the explanation? Let's go. Let's start the animation video.
LNG Carrier Mode depend into the type of floating storage and regasification unit or FSRU. Some of FSRU equipped with propulsion unit and some of them is not equipped. It is depending into the necessity and the project they run into. For FSRU, which is equipped with propulsion engine, they able to shift easily from one project to another place. Meanwhile, for non-propulsion engine, this type of FSRU require to use towing bars for moving from one place to another. This animation based on FSRU with electric propulsion motor with dual fuel diesel engine or DFDE as main generator engine. This type of FSRU can be changed its mode from LNG carrier mode to FSRU mode. Under LNG carrier mode as a vessel, FSRU transporting LNG by loading from LNG terminal toward to discharging terminal or regasification terminal. During transportation, FSRU using its electric propulsion motor to sail across the ocean. The electric propulsion motor receives power from electric generated by the FDE. Dual fuel diesel engine is engine that able to use both fuel oil and natural gas as fuel for its combustion. DFDE use low sulfur MDO or MGO as main fuel and pilot fuel. And for fuel gas, DFDE receive natural gas or known as boil-off gas or BOG from cargo tank. LNG cargo in the cargo tank always generates BOG due to natural convection and it is unavoidable. Generated BOG must be removed in order to preserve the tank pressure. For details about natural convection, please watch my previous video about natural convection, stratification, and rollover. BOG then compressed by low-duty compressor, then supplied to DFDE as fuel gas. Gas combustion unit used for burning excess BOG from cargo tank, which is not used by DFDE or other engine in order to maintain tank pressure. Ensuring the secure disposal of BOG that inevitably releases from LNG cargo, preventing releasing methane direct to the atmosphere. FSRU mode, closed loop glycol water indirect heating methods. When FSRU arrive at the regasification terminal, the operational mode changes from LNG carrier mode to FSRU mode. In this animation, the regasification is closed loop glycol water indirect heating methods. LNG vaporizer indirect heating methods use seawater as the heating media to heat up glycol water. Then heated glycol water vaporizes LNG at LNG vaporizer. Seawater taken from outside from sea chest then discharged to overboard. This system called as open loop system. Meanwhile, heated glycol water is a closed-loop system, recirculated on the glycol water system. This indirect method is most suitable to be used at tropical area, with seawater having temperature between 28 degrees Celsius to 32 degrees Celsius. This temperature is enough to vaporize LNG to natural gas or NG with outlet temperature about 14 degrees Celsius to 23 degrees Celsius. It is energy safe, effective, and efficient since it did not require any steam energy to heating up glycol water. Before entering the system, seawater treated with MGPS injection to preventing any marine growth on the seawater piping system. Then filter at autofilter to remove any dirt from seawater to prevent clogging on the glycol water heater. Glycol water heater is plate heat exchanger type. The hot and cold fluid stream flow in alternate channels separated by the plate. Glycol water heater is a type of heater that uses a glycol solution or a mixture of glycol and water as an intermediate fluid to transfer heat from seawater on the glycol water heater to efficiently vaporize LNG. In order to meet the environmental regulation, the maximum seawater temperature differential between inlet or sea suction and outlet or overboard is 7 degrees Celsius. In order to introduce the LNG to the regasification system, the glycol water and seawater heating system should be running in advance. Regasification with suction drum mode. LNG inside of cargo tank is stored for the purpose of reserve of gas fuel for consumer. Usually, the main consumer is power plant for fueling their gas engine or boiler. LNG can be used as fuel in the form of gas. Therefore, regasification is required to transform the states of LNG from liquid state to gas state. During storage, LNG generates BOG, which must be removed in order to preserve tank pressure. BOG consumed by boiler and DFG as fuel, and the excess BOG to be burned at GCU to prevent releasing of methane to atmosphere. To supply LNG to regasification system, feed pump or emergency cargo pump used to feed recondenser and high pressure booster pump. Before filling LNG to regasification pipeline and equipment, it is necessary to carry out cool down operation. The cool down operation is carried out in order to lower the regas system such as pipe and equipment temperature close to fully refrigerated condition prior to the regas operation. This will prevent any undesirable shock cooling of the regas system and minimize the amount of liquid flashes within the pipe and equipment. The cool down will be carried out before LNG is supplied to regas system using stripping or spray pump. In the initial state of cool down operation, the small inlet control valve should be kept 10% open manually to cool down pipeline and regas equipment by displacing vapors in piping or LNG heater from cargo tanks to recondenser or suction drum. When the cool down is finished, LNG can be filled to suction drum or recondenser with pressure about 4.5 bar using feed pump. Recondenser can be operated in two modes, suction drum mode and recondenser mode. In suction drum mode, recondenser used as buffer tank for feeding high pressure booster pump. Meanwhile, in recondenser mode, recondenser used as buffer tank and condensed BOG which is generated from cargo tank. Initially, recondenser under suction drum mode. In this mode, the suction drum works without BOG flow. About 12 hours before intended startup of regasification operation, the cool down of high pressure booster pump, pots and pump should be started. The cool down is done by gradually raising the level of LNG in the pump pots by feeding LNG through the filling or drain line at the bottom of each pump pot. After the suction pot has been filled with liquid, observe a 3-hour soak time. The pump shall remain submerged for a minimum of 3 hours to allow the thermal stabilization of all internal components. High pressure booster pump used to pressurize LNG from about 5 bar to about 90 bar, then delivered to high pressure vaporizer to be vaporized. High pressure gas is required due to the location of FSRU is miles away from power plant, where the natural gas is consumed as fuel for turbine gas engine or boiler to generate electricity. LNG from HP booster pump entering inlet of high pressure vaporizer with pressure about 90 bar and temperature between minus 145 degrees Celsius to minus 150 degrees Celsius. LNG, which is under liquid form, converted to gas form by transferring heat energy from glycol water to LNG, with outlet temperature from vaporizer about 14 degrees Celsius to 23 degrees Celsius. Glycol water inlet temperature about 21 degrees Celsius to 28 degrees Celsius, and at the outlet about 6 degrees Celsius to 14 degrees Celsius. Regasification with recondenser mode. The BOG generated from cargo tanks is consumed mainly as fuel, and excess BOG will be burned at GCU. The concept of recondenser mode is to save BOG from disposal at GCU by recondense the excess quantity of BOG and send it for regasification. The process is by increasing send-out capacity and slowly reducing GCU flow. In parallel, BOG is supplied to recondenser. When gas flow to GCU reaches at minimum flow, GCU then stop it and all excess BOG shifted to recondenser. Condensation of BOG shall be achieved by packing between subcooled LNG from feed pump and compressed BOG from Rodoti compressor inside recondenser under recondenser mode. The regasification process between suction mode and recondenser mode is same. The difference is the function of recondenser. In recondenser mode, recondenser having two functions. One, used as buffer tank for feeding high pressure booster pump. 2. To condense excess BOG which is generated from cargo tank. High pressure natural gas which is converted from liquefied natural gas by a vaporizer then delivered to power plant at shore. The pressure to be maintained about 70 bar or as per the requirement by power plant. Natural gas sent out measured in mmSCFD or million standard cubic feet, where mm in mmSCFD stand for 1000 times 1000.
I think that's all my video about FSRU story part 2. Thank you for watching my video. I hope that my video has provided valuable insight into process of LNG regasification, its significance in the energy industry, and its contribution to a greener planet. Remember to like, share, and subscribe for more informative content on maritime world. See you in my next video. Bye-bye.
Your contribution by subscribing to my channel is highly appreciated. It is for development of my channel. May your sails be full, your compass true, and your journey in marine engineering be filled with success and fulfillment. Fair winds, following seas, and smooth sailing to you all.
Thank you for watching my video. Terima kasih. Di Antonio Project.